get the M.
Parallel or
So,
perpendicular?
لا tangent is parallel to the curve at that point. Try solving the question, then look at the answer.
Omar, which part are you on? Lee, Omar, are you working? Do I have all the Vietnamese students? I feel like I don't. One of them's missing.
Ian is not here.
Ian and someone else. No, took right there.
Yeah, Duklong, where is Duklong? Where is Vietnam? Oh, because I didn't turn all the way back. Yeah, so it's only Duklong. Unless he's behind Vietnam.
Wait, Duklong's missing?
Do you know how Duklong is?
What's Duklong?
No, that's long.
Not this long.
No, you're the
Oh,
Yeah, so you don't know who your other student is.
that's a good thing.
Yeah, other than Umar, now we have someone else. We have a new Umar in town.
In fairness, I think Long is in both their names, so cut me some slack. It's important I don't mix that up for the attendance. Duck Long is missing. You are.
He's long.
You can be alternative Long.
No, he's long.
Long.
Yes, long leg.
What's your middle name?
Juan.
What's his middle name?
What?
Juan, not Juan.
Different than
Juan.
This is what I hear. Wong. No, his name is Wong. Like,
No, it's S-O-I-N-G.
Wong.
Juan.
yeah. Oh, so different. I kind of like the idea of long or alternative long or alt long. Long alt. Alternative long or alt long.
You want to be the alternative?
That's true, actually. He could be original long and duck long. Yes. Yeah.
Tall long and short long.
No, that could upset people. No, we won't do that.
Long too.
Oh, definitely not. Long and short long. Alright. Are we nearly finished this one? Andrew, what part are you on?
Second last.
Second last, good, okay. Lucas? It's okay, yes. So only one person's finished. Finished or finishing?
Finish.
And is it right?
I can check.
Please do. I'll do it now. I have to turn this now. Okay, let's have a look at it. Here. Okay. I won't. Yeah, we're going to have a look at it now. Where is Ian actually?
He lost his GNIB card, so I went to see it.
Yeah, the problem.
Sorry, I was there when he lost it, so that's why I'm laughing.
Oh, really?
Yeah. No, I'm not saying there's a connection.
Like, I thought, like, he doesn't know where it is.
Yeah, he lost it. Yeah, I was there when that
He
happened.
discovered that he lost it.
Yes,
Oh.
yes. So I'm laughing because I realise now he never actually found it. Because I was joking that he would have to go to GNIB now. It looks like he does have to go to GNIB. So who's going to GNIB tomorrow? You'll have company tomorrow. You didn't actually take the card, did you? No. You're like, I want to go with someone. Alright, B6. We have a quadratic, and the quadratic has 2 points on it. Find the equation of the line AB. Well, that's pretty easy because that's just actually the first lesson that we had. There's A, there's B. So first let's get the M. Y2 minus Y1 over X2 minus X1 minus 8 over 4 minus 2. Did you get that? Yeah. Guys, come on. Y equals mx plus c. I'll put this in to get the c. And I have 12 equals minus 4 plus c. C equals 16. So you should have y equals minus 2x plus 16, I hope.
Yeah.
Okay. Will we go on to the next part now? Yeah. Next part. Is it okay, guys? Yep, okay. Part 2. Find the tangent at B. So we have the point B, but what are we missing here? We don't know the slope. But we can get the slope using the derivative. Mm-hmm. The derivative is 2x minus 10, and the point is 6.
Yeah.
So it's 2. So the slope is 2. So we have y equals 2x plus c. Put in the point. 4 equals 12 plus c. So c equals minus 8.
Yeah.
Y is 2x minus 8.
I got lost.
Where?
After second part.
Which part?
Like I got 2x minus 10.
Minus 10.
Like the first part, the derivative, I got.
Yeah, and you put in x is 6.
Yeah.
And you got 2.
Yeah.
So what's the problem? Y equals 2x plus c.
Did you
I
use...
didn't do that.
Oh.
What did you do? Y minus Y1?
No.
Oh.
Right, next part. The tangent at point B meets the x-axis at x, some x point. Find this point. So, what do we do to find this tangent point? Where the tangent crosses the x-axis.
Y equals 0.
Yeah, y equals 0. What's another name for this point?
Intersection with...
No! No!
Not intersection.
The root.
The root, yes. 0 equals 2x minus 8, so x equals 4. Okay? Next. This last part of the question is very generously marked.
Yes, 8 marks.
It's 8 marks, which is a tremendous amount for one part of one question, and it's not even that difficult. They want the area. So, For the last part here, can I scroll down?
If you want to.
Yes. For the last part, we want the area. And what's nice is we can see the beginning and the end values. Where is the lower limit?
The
2.
The curve.
Just give me a number, Faisal, not a sentence. What's the lower limit?
2.
And the upper limit?
6.
Thank you. And we have, if you remember, for area in between curves, it's the upper curve minus the lower curve. Which is the upper here, the line or the quadratic?
Line.
The line. And do we have the equation of the line? I think we do. We found it. What was it?
Minus 2x plus 16.
Thank you. Minus 2x plus 16. Minus the lower curve, which is the quadratic, which is given to us. X squared minus 10x plus 28. So the question is simply to integrate this quadratic. Minus x squared, that's positive 10x minus 2x is 8x. That's, what was that at the end? Minus 28 plus 16. Minus 12? So all we have to do is integrate this quadratic and we have 8 marks. Let's do that now. So we have minus x cubed over 3 plus 4x squared minus 12x. And we have to put in 2 and 6. So we'll put in 6, we'll put in 2, we subtract and we get the answer. So whatever minus 6 cubed over 3 is, plus whatever 4 times 36 is, 144?
Yeah.
Minus 72?
Yeah.
Is it? Don't just say yes because you
No,
want me to
it's-
feel good about myself. Is it
Yes,
right?
it is.
It is? And then we put in 2, which is minus 8 over 3, plus 16, minus 24. Does someone have this typed in? Let's type it in now. So, minus 6 power 3 over 3, plus 144, minus 72, plus 8 over 3, minus 16, plus 24. 32 over 3? Did anyone get that? I have no idea how to answer that question.
Yeah, 32 over 3 is the answer.
Now, we can know if it's right because our calculator can integrate. Let's check if it's right. Lower limit was 2 and upper limit was 6. And inside here we have something minus something. The line is first, what was the line? Minus 2x
Plus 16.
plus 16?
Yeah.
And then the quadratic here, which was x squared minus 10x
Plus 28.
plus 28. So in the exam, I know for a fact I have all 8 marks available here.
Can we do it using the trapezium way?
Oh my goodness, I'm so tired of hearing that word.
You
No,
It's
no, no.
Of course you get the same.
But I think that's the way it's done in the market.
Yeah, but remember, your teacher is lazy. He will find the easiest, quickest way to do it.
Trapezium one is easier.
You think that's easier than this?
Yes,
No.
the calculating the area of trapezium is easy.
But all you've done, right, by using trapezium, you've cancelled this part, yes? And then you have to use the trapezium formula, which you have to memorize and calculate, whereas I just put that into the quadratic. You have to integrate anyways. Did you have to integrate quadratic? Yes or no? Yeah, so let's compare the methods. Me, integrate quadratic. You, integrate quadratic and use trapezium rule. My way. Maybe? No? Okay. Okay, I see I'm not going to convince you. But trust me, this is the quickest, easiest way to get 8 marks. Did you write less than this?
Lies.
Don't turn my classroom into a room of lies, please.
It's probably the same amount.
Or a little more, possibly.
No.
Okay. To answer your question seriously, yes, you can do it that way. And in fact, I'm quite surprised that usually in the marking scheme they do it that way, which I find totally strange because I just think this is easier. But you're absolutely right. If you want to use it, you can. But the disadvantage is that formula is not in the formula book, so it'd be your responsibility to remember it then. Go on, please. Okay. So what we're going to do now is have a look at the workbook, because some people had questions from the workbook. So, you had some questions too, and you had some questions. So where are we starting? What lesson?
No, I just wanted.
Oh, okay. Karen, where are we starting?
What question?
Yeah, which one? Sample space, trees? Okay, and which question? Can everybody open up the worksheet on probability trees? Lucas, can you close the door? The door, please close. Thank you. Right, are we all looking at the probability tree lesson, please? Okay, Karen, which question? 11. Okay. Let's all have a look at number 11 on that lesson, please. Can I scroll down now? Yep, okay. On the probability trees. Okay. Let's have a look. If you don't have it open, you'll have to listen very carefully. Suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car, behind the others, goats. You pick a door and the host, who knows what's behind the doors, opens the other door which has a goat. And he says, do you want to change your choice? So let me explain what's happening here. Everybody's attention, please.
Boom! I was waiting for it to look at your screen.
Attention, please. Thank you. So, for this game, there are 3 doors, and behind one of the doors is the prize. So, behind one of the doors you win, and behind the other 2 you lose. And of course, you don't know which door will be the winning door and which door will be the losing door, obviously, because then it's not really a game. So the way the game works is you have 3 choices. You can choose door A, door B, and door C. So let's imagine in this game you choose door B, for example. But you don't know if you win or lose yet. You don't know. Okay, so you choose door B. Then what happens, the person running the game says, look behind door C. The prize is not in door C. And then he asks you, do you want to keep your choice of B, or would you like to swap it and choose A? Yeah. So he always picks a door that was a losing door. So you don't know if the door you have is winning or losing. He just showed you that one of the other doors is losing door. And he said, would you like to stick with your choice, or would you like to swap? So in this example, if the person picked B, should they stay or should they swap? They should swap, but of course they don't know that until at the end. Until the doors are opened. Okay? So the first question here, before the game starts, you decided you will never change your mind. What's the probability you will win the car? So before the game starts, you decided no matter what happens, I am not changing my mind. Let's have a look at the probability tree. So, at the very beginning, you have 3 doors to pick. You can pick the first door. Guys, please. This is your choices. At the very beginning, you can pick a winning door, a losing door, or a losing door. The chance that you pick the winning door? 1/3. Losing door? 1/3. 1 over 3. And then the next part of the game, he says, would you like to keep or would you like to change? Okay, so in this situation, you have two branches. Yeah, now you decided at the very beginning you're always going to keep with your choice. So it's going to be a 1, and probability of changing your mind, 0. Because you said at the beginning, I am not changing my mind. I'm sticking with my choice. So this one, 1 and 0. This one, 1 and 0.
But wasn't that like one of the doors?
Keep, change, keep, change, keep, change.
Yeah, but he revealed that that door is like a losing door.
Oh, sorry. If you pick this door, he will reveal one of the other doors.
Oh.
Yeah. And you decided you will keep with this choice. So in this situation, if you pick this one at the beginning and you keep your choice at the end, then do you win or lose?
You win.
You win. Now here you lose. But this never happens because at the very beginning you said you're not changing your mind. Now here, if you pick this door and you keep your choice, you will
Lose.
sorry, what am I saying? You will lose. And here, if you lose and change, well,
No,
you
you
don't know
cannot win.
because, yeah, half the time you will win and half you will lose, but it doesn't matter because this doesn't happen, yeah?
But it says that you always choose the goal.
Yeah, the person who opens the door always picks a losing door. So now you're left with two choices. The door you picked at the start, or the other door.
Yeah, but then you don't know which one is, like whether the one you have now.
Exactly, that's
And
the
the
point.
losing door.
That's the point, yeah.
He might just show you the goat even if you have the losing.
Exactly, that's the point, yeah. He will always show you a goat. He'll always show you a losing door.
So why
He
do
never
we-
shows you the winning door.
So why do we still have 3?
Okay,
This is before he shows you.
let me simplify
okay.
it.
After he shows you, you don't change your mind.
Here.
Yeah.
Okay, well, I'll just draw the tree again. And this, I'll just make it clear, this is at the, before he opens the door. You have to make a choice. Door A, B, or C. So you could choose A, which could be maybe the winning door, losing door, losing door. So you have 3 choices here. Then, he opens the door, and he shows you a losing door. So now what are your choices? You can keep your door, or you can change your mind. If you had the right door at the beginning, and you keep that choice at the very end, you win. If you change your mind, you lose. Now this one is more interesting. If you pick a losing door,
You lose.
and you keep your choice, you lose. But if you change your mind,
Maybe
1 over 2.
maybe you pick the right one, maybe you pick the wrong one. It's a 50-50 then. Yeah, because there's 2 doors left. One of them is the prize, and one of them is the losing door.
After he opened,
Yeah.
you choose a door, then he opens one. Then he asks you to change. So you have 2 options to pick from after you...
So you
Hang on.
either you keep it or
Wait.
you change your mind.
Wait! I'll explain with cups.
They're mine.
Not at the moment. One of them has a prize. Okay?
Is that the goat?
Well, yeah, one of them has a prize. And the other 2 are empty.
Okay.
So at the very beginning, you pick one. So pick one, for example, A, B, or C. Now, actually, you know what? Close your eyes for a second. All right, I shoveled them up. Right, pick one, A, B, or C. No, don't. Hey, C, don't react. Right, turn around. I'll shuffle them up again. All right, don't react. All right, come out. A, B, C.
See.
Okay, so you pick C. All right. So what I do now is I show you one of these,
Okay.
and I always pick one that's empty.
Oh,
So
you
now I say,
always-
I always pick one that's empty. Now I say, you can keep your original choice, or You can change your mind.
I keep it.
You keep it. You sure? This is how the game works. Clear?
You can keep the cup.
So in this case, you made the wrong choice. You should have changed your mind. The prize is in the other one. Yeah?
Show the probability.
Yes.
Again with the probability. So that
Let's say if I pick the loose one first, and then you reveal the other one,
And you change your mind,
and I change my mind.
You
and
then you win.
Yeah. What's the probability?
Well, that's what I'm doing now, so I'll write it down, okay? Alright. So in this situation, if you pick the losing door at the beginning and keep your choice, you lose. If you pick the losing door at the beginning and change your mind, you win. No, you will win. Because there's only 2 cups.
But
And
you
if you
don't
pick...
know.
No, don't talk, please, Faisal. Let me explain. There's only 2 cups. If you pick the losing one at the start, the other one must be the winning one. It must be. So if you change your mind, you automatically win if you pick the losing one at the start. So here, you lose and you change your mind, the result is you win. Now, if you pick the other losing door at the start and you keep your choice, what happens? You lose. And if you change your mind, you win. This is what the tree looks like. Now, let's answer part A finally. You decide no matter what happens, you never change your mind. So here we have 1 over 3, 1 over 3, 1 over 3. Here, 1, 0, 1, 0, 1, 0. Because you said at the very beginning, no matter what happens, I am keeping my choice. I want everybody to calculate the probability that you will win. So it will be this times this plus this times this, which is 0, plus this times this, which is 0. So for part A, the probability that you win is what?
1 over 3.
1 over 3. Okay, that's part A. Now on to part B. In part B, before the game starts, you decide you will always change your mind. No matter what happens, you will always change your mind. Let's see what happens now. No.
no.
No, Faisal. No. I'm sorry. I'm continuing. Okay, for part B, you decided you will always change your mind, no matter what happens. So these probabilities here, they get flipped around. So this 0 and this one 1, this one 0 and this one 1, 0 and 1. Now let's calculate the probability that you win. So the first one is 1 over 3 times 0. 0 plus 1 over 3 times 1 plus 1 over 3 times 1. It was this plus this plus this one. Did I get that in okay? Yeah. So, well, it's 0, so why is it 0? Oh, because if you pick the winning one at the start and you said you will always change your mind, then you always lose. Because you had the winning one at the start and you said, no, I'll pick the other door. So then you made the wrong choice. You picked to throw away your choice and go with the losing door. Yeah? So here you get total. That is much different than the previous answer. Right? So the last part here is, therefore, what should you do? You should always change your mind. This makes your chance of winning twice as big. If you always keep your choice, your chance of winning is 1 over 3 in the original one. But if you always change your mind, your chance of winning is 2 over 3, which is twice as good. Yeah? So the best way to play this game is to always change your mind.
But then they reveal one of the cups.
No, you see, the problem is you're thinking about it. The math says the best thing to do is to change your mind.
Yeah, but then when they reveal one of the
Yeah.
cups, then you're left with two options.
And you're going to say it's a 50-50.
Yeah.
And this is the whole reason I put this question in here. This actually, by the way, this is a famous probability question. It's called, I think, the Monte Carlo problem. And the problem with this one is everybody thinks your chance of winning is 50% when you change your mind. But when you actually calculate it, your chance of winning is 67%. And if you ask 100 people what the answer is, 99 of them will get it wrong. Only will you get the right answer by calculating. So this is a famous probability question called the Monte Carlo game, Monte Carlo problem. And if you Google it, you will get millions of websites if you want to look up more about it. Yeah, anybody who wants to look this up?
I'm pretty sure it's Monty Hall.
Oh, sorry, not Monte Carlo, something else. Monty Hall, is it? Yeah. Game or something? Game, yeah.
Two dogs and one.
Two goats and a sports car, yeah.
Hall.
Yes! Hall! Correct. Alright, that was quite difficult. Close? Yeah? Okay, good, yeah. Alright.
But hall in here, same hall we talk.
No! This hall means a big room, which is another meaning of hall. I know, English sucks. Right, question, yes.
In B, how do you change our mind and stay with the same girl?
What do you mean, in B?
Yeah.
You always change your mind.
Yeah, but previous question.
Calculate. Oh, sorry. Sorry, that's me typing it. I should have said, if you always change your mind and don't go with the door you picked at the start. What happened here is I copied, pasted part A, and I didn't change all the words I needed to. That's what happened there. Sorry about that, Yusuf. Okay, next question. Next lesson, or this lesson number 9? Okay, let's have a look at number 9. Can I scroll down? Yep. Okay. Now, Faisal, you may ask that question. If you forgot it, it meant it wasn't really that important to ask.
No, I remember it.
What is your question? Yes?
No, I remember it very well. When you choose a door,
Yes.
the first probability of winning is 1/3.
Yes.
And then one door is gone.
Yeah. You are asking the exact same question he's asking.
Exactly. It's not getting into my head.
I know.
Because in the second
I
time...
know. This is a thought-provoking, deep probability question that you're supposed to think about on the bus journey home.
Not really.
Yes, really. Really.
But then one of the doors.
No, you're asking me to explain it. The answer is within you. You must think about it deeply.
Yes, if you take it as a one...
Think deep. Meditate on it.
If it's
I am
one
go-
event, then it is a tree
Yeah.
diagram.
No. Think deeply. And tomorrow we will talk about it. You will need to spend at least one night on it. Okay?
Okay. Question.
Tomorrow.
No,
Question.
right now.
Right.
You have two doors.
No.
One has...
Stop.
One you win, one you lose.
I'm telling you, tomorrow. 9. A student can either study for less than 25 hours, between 25 and 50, or more than 50 hours. So we have 3 choices. They can study a small amount, a medium amount, or a large amount, basically. If they study a little bit, then the chance that they fail, get an F, is 0.8. So what's the chance that they pass? Yeah, pass is 0.1, and there's another grade here which I call a merit, which is like a high pass, also 0.1. So let me just write that a little bit neater. So here we have merit, pass, fail, merit, pass, fail, merit, pass, fail. merit, pass, fail, merit, pass, fail, merit, pass, fail. So here it's 0.8, 0.1, 0.1. Now, if they study a medium amount, the chance that they fail is 0.1, and the probability that they pass is 0.8. And merit therefore must be 0.1. And finally, if they study more than 50 hours, the probability that they will fail is 0, pass 0.5 and merit 0.5. 0, 0.5, 0.5. And you have 30 students in the class. So to answer the first part, how many will get a merit? Did I say? Oh yes, and then the last part. In a school, the number of students that study for more than 50 hours is twice as many that study for between 25 and 50 hours, which is also twice as many than those who study for 25 hours. So what you're saying is, here there's twice as many that study compared to here, and here twice as many that study compared to this one. So if this is an x, yeah, this one must be a 2x, and this one must be a 4x. This should all add up to
7.
probability 1. So you get 7x equals 1, so what's x? Yeah, so Karen, you got the probabilities now. This one is 1 over 7, this one is 2 over 7, and this one here is 4 over 7. So we can answer how many will get a merit. That will be 30 multiplied the probability of a merit, which is 30 multiplied by 4 over 7 times 0.1 plus 2 over 7 times 0.1 plus 1 over 7 times 1 over 2, yeah. And the reason I multiply by 30 is because there's 30 students, and this is the probability, like a percentage. So I don't think I have to continue with this. Was it probably this part here? Yeah. Did you have more questions? That was it? Perfect. We'll finish there, so...